Hi everyone, welcome to our final video in this series. This is just a slightly conceptual video talking about one more idea centered around inverse functions. Now, we've looked at a bunch of different examples in the last couple of videos, and the only thing I'm going to do here is going to write one particular definitional idea behind inverse functions, and then we're going to explore this a bit and relate it to some previous videos and concepts. So I'm going to write here graphically a function has an inverse function if it passes the horizontal line test. Okay, let's see what that actually means in just a second. Now, you guys are probably looking at this and going, well, we know about the vertical line test, we've heard about that before, but why now are we talking about this horizontal line test? So let's actually just draw a function here. I'm going to draw the function y equals to x squared. This is just a regular parabola, and we are going to draw a horizontal line through, and in the same way as with our vertical line test, it's going to tell us something about our inverse, or whether this can have an inverse. Now, if I draw a horizontal line through, I can see that this function fails the vertical line test, because I can see there are 2 points where my horizontal line crosses my actual function. So this particular function in its current form cannot have an inverse function. Now let's talk about why. Now, if I rub all of this out, we're going to just make one little observation. Now, if we were to draw an inverse to this, remember from the previous video, that's the effect of the x and y having different roles. So this would be something that looks like, instead of y equals x squared, x equals y squared. So that's going to look something like this. It's a parabola rotated along here. Okay, now this thing is the graph of x equals y squared. Now let's actually just look at what the significance is of the horizontal line test we talked about before. Now, first of all, this looks like what we talked about as an inverse because it's reflected along the line y equals x. We can kind of see that. But if we look at this second green graph I've drawn, it's actually not a function. Why is it not a function? Because it fails the vertical line test. If I draw a vertical line through, I'm crossing at 2 points. So that means that one value of x produces 2 values of y. Hence, this violates the rule for what constitutes a function. So this thing here is not a function. It resembles an inverse in the sense of the x and y having opposite roles, switching roles, and it reflects along this line, but this graph here is no longer a function. It fails the vertical line test. So this is the equivalent. The reason we talk about this horizontal line test is that's because it's the equivalent of when we do the inverse, when we reflect this along, that corresponds to a horizontal line test of my original corresponds to the vertical line test of my quote-unquote inverse. But here, this is not an inverse function, so it doesn't actually work, because this is not a function like we said before. So for a function to have an inverse, as we said, it needs to pass this horizontal line test. If it does not, it will not have an inverse function. Now, if we look at my particular parabola here, we can do something similar to what we've been doing before. We can restrict variables. So we can make a restriction on the value of some of the variables in my function in order to produce an inverse function. So I can see that the problem with my parabola is that it goes down here and then it comes back up. Now, this idea of the symmetry around my y-axis, that's what's giving us problems. Now, what happens if I reduce or restrict the x values on this function? What if I only took these particular values? So if I rubbed this out, then that would correspond to rubbing this out on my green graph. And now I can see that the results I get by restricting the variables, so in this particular example, I restricted the variables to only x being greater than or equal to 0. We've practiced this before in this series, but the effect of doing that creates half a parabola, but now this passes the horizontal line test because one value of x produces one value of y. And that means that the resulting thing I get when I replace, or when I swap over my x's and my y's, is an inverse function. This guy here in green is an inverse, and it is also a function because it passes the vertical line test, where each value of x produces one value of y. So this is indeed now a function. So let's just quickly recap the main ideas from this video. So graphically, a function has an inverse function if it passes the horizontal line test. My original parabola didn't pass this horizontal line test, but in order to make it so it can have an inverse, we can restrict the variables. Now, we can do this in any number of ways, but here I've restricted the variables to just a value of x that is greater or equal to 0. So just on this right hand side of my y-axis. And once I do that, the resulting thing I get when I reflect this along the line y equals x is now a function. So restricting variables, they have a purpose. From what we did in the last, I think maybe 4 videos ago, now we can apply these ideas, restrict variables on our graphs in order to produce an inverse function. Now we have our original function. This guy here in black, that's our function. And the thing in green is our inverse function. And we got here by restricting some variables. That brings us to the end of the video and the series. Thank you so much for joining me, and I will see you next time.